I need to actually share it. All right, let's start sharing it. And here's NetBeans. Now, I actually did something. I noticed that in my my code, I had been for some reason using the Java 13. What I've done is I've changed that to Java 8. So when you pull my code, if there's something that goes awry with that, it's because of that. Well, I'll wait for any issues that that have to do with that. What I do want to point out first is just something that I wanted to get to earlier this morning, and that's just a simple example of using a listener. And in this case, it has a parameter. You're not going to use a parameter in the code that you have, but anyway, in my code, and I think it should be pushed. Here's a simple listener, and the idea is that this simple listener is going to listen for that for loop. Remember, we had this for loop, the for loop that simply schedule these init events. Okay, so now what this listener is going to do is this is going to listen for the init event with the right argument within an int, and it's just going to schedule an event called double. And what that's going to do is that's going to double the value of the int that it heard. And the double event is not going to do anything. But it's going to show up on the event list just to just to show that it's happening. So, and again, normally the main method should be in a different class. The way I've asked you to do a separate run class. But again, just for this simple example, that's a little bit of overkill. Okay, so here I've instantiated a for loop with 6, that's going to do 6 of them. Here I instantiate the simple listener. Again, it has no parameters, so there's only the empty constructor. And then here's where you hook up the SimEventListening. So this, and it, I sometimes get a little confused with it myself. So you say, add SimEventListener to the source, and then pass it the listener. So in this case, it's the for loop, you add SimEventListener, and then pass it the simple listener. And then again, just to show what you get with the print lines here. And then we don't need to artificially stop it because the init, the for loop is going to just end things. So when we run that, what you see is, again, so here's the result of the print line. So the for loop had a parameter, the max number of 6. The simple listener had a had no parameters, so it was just listed there. You might be wondering what these numbers are. Again, in the overridden toString method in SimEntityBase, what it does is it just gives every time you instantiate a subclass of SimEntityBase, it just increments a counter, similar to something that was done in the Java class. So the for loop was the first one instantiated, so it got an ID of 1. The simple listener was the second one, so it got an ID of 2. If we reverse that, then the IDs would be different. But again, that's just for identification purposes, not for any, it doesn't really affect anything. Okay, so we start with a run, and this is the run for the for loop. And as we'll see with the second assignment with the SimpleServer module, it will have a run event, and so there will actually be 2 run events at the very beginning, one for the arrival process and one for your SimpleServer. But anyway, the event list still processes exactly the same way. You advance time to the next event, and in that case, this is the run event. So the current event is run, and it schedules init, and that's all it does. Okay, so now the init 0 event has been scheduled. and it schedules an init1. But then notice here that even though it was the init event in the for loop object that got executed, here's the double event that was scheduled. And how did that happen? Well, because this simple listener object was listening to the for loop object. When the for loop when the event list executed the init event for the for loop, after it did its thing, notified all of its listeners, and one of its listeners, its only listener in this case, was the simple listener. It heard the do init event with the right argument, and so it scheduled the double event with a delay of 0 and passing it twice the value of I. Now, we can't completely verify that because twice 0 is 0. So, but we'll see in the second one here. So init1 schedules an init2, and the simple listener will now schedule a double 2, because 2 times 1 is 2, last I checked. Okay, but now notice, and this is important, the init event was the one that was processed. The double event was on the event list, and so it didn't go anywhere. It's still there. So the very next event to occur in this case would be the double, and again, it doesn't do anything. So if you look through this, then we see that we get exactly 6 of these init events, and then by the time everything finishes, we get exactly 6 of the double events. Okay, so that's just a bare bones simple example of the listeners. Okay, so now let's move to what we're going to be doing here. So just in following the handout, first thing to do is we're going to create a new class called SimpleServer, and we're going to put it in the MV3302 package. Then we have it extend SimEntityBase. We get a red squiggly. It can't find the symbol. And so one thing we can do is click on the little light bulb and say add import. So we add the import. Everything is fine. Okay. Now, the first thing to do is to define the parameters. And there's a table on the second page of the handout that shows the parameters would be the total number of servers, that's K, and the service time generator. So that's if you remember in the arrival process, our inter-arrival times we called the inter-arrival time generator. Here, we're going to generate the service times with the service time generator. So okay, so here's our first parameter. And here's our second parameter. Doesn't like that. Okay, and then it doesn't like random variate, and so we need to import it. Let's, come on. All right. What we wouldn't hurt to write the constructors. And those would be, and what you can call them whatever you want, but I've taken to actually calling them by the same name. course, I fat-fingered tour. Okay. And then we want to generate the setters and getters. And so to that, we encapsulate our fields. We make sure our field visibility is private, got all the setters, got all the getters. We want to do it as the last method. So refactor. And then in the master constructor, we simply, okay, so in the master constructor, we invoke the setters for all of our parameters. Okay, so that's step one. We haven't, one thing we need to do is to put a little gate around the total number of servers that make sure that it's always greater than 0. I'm gonna let you do that. That has to be done. But again, I'm not going to do everything here. But okay, now notice what I did. I defined the class. I defined the parameters. I wrote the constructors, in fact, and then I generated the setters and getters. Okay, that's actually enough to kind of see what this object is doing. So let's write a main method, and I noticed in some of the first projects, the main class was put in the same package. Again, there's nothing really terribly wrong with that. It's just that it's usually better to separate the components from the main method. But you know, I may complain about that more in the future. But for now, if that's what you're doing, I would make sure that you're not doing it just to avoid, just because you were getting errors when you tried to do it the other way. I would encourage you to refactor your classes to put everything into one of these run packages. Anyway. All right, so let's okay, so remember, where I am is in the main method, and just as we did with the
Sir, you have a typo on line 15.
Oh yeah, thank you. Yeah, actually, that wouldn't have made any difference, to be honest. But yes, that was not the intent. So all right. Now here we're gonna. I think in the handout I ask you to kind of let's sort of fix the imports at least. Just put a placeholder to do. I think I asked you to give these as sort of local variables. That's actually not a terrible idea. It's not a bad idea. What are the values that I ask you to do? Well, I forget the exact values, but I'm going to put in just some arbitrary values here, so we can easily change them later. Okay, so and again, I haven't. I think I've mentioned something called the gamma distribution. You may not have encountered it before. But until we, darn, my voice is killing me. Okay. So until then, just kind of follow this in the random variable thread that I've haven't been able to get to. I will get around to at least sort of showing you what the random variable, what the gamma random variable is. In the meantime, you can Google it and find out for yourself as well. All right, so let's instantiate our Simple server and give it the service time generator. And that should be enough to at least verify that our parameters have gotten in. Okay, so yeah, so it had given me the wrong one there. I need to say get instance. So if there are discrete random variables and there are continuous random variables, gamma is a continuous one. And what I was asking the random variate factory to do was to give me a discrete one. And it said, hey, gamma, you're saying to give me a gamma that's a discrete, and gamma is not a discrete. So it says, I'm not going to do that. So let's try this again. Okay, so now we see that our service time generator is null. Why is it null? It should not have been null. And okay, so actually this is a, or maybe this is what you were pointing out here. Notice that I've fat-fingered service time generator here, and this is actually a good lesson. You're doing this to me. Okay, so I ran this, and service time generator came up null. So if I were to just continue from here, then by the time I actually tried to execute something and I tried to use that service time generator, I'd get a null pointer exception and I would be wondering why. So this is actually, now this was not intentional on my part. I'll have to say that this was actually a genuine fat finger. Part of it's because I can't see the right side of the screen because the Zoom windows keep covering it up. So that's my excuse. But okay, notice here, I meant to say service time generator, but I said service time generate tot. And since I had the same name in both places, it said, oh, you mean the instance variable. Well, the instance variable is null. So just, it would be useful for you to, again, understand why this happened. Because I guarantee you, if it happens to me, it will happen to you. Okay. So actually, see, what I was going to do is I was going to comment this out just to show you what happens. But instead, my inadvertent error allowed me to actually show you what I intended to anyway. Okay, so now that that's fixed, you don't move on, or I mean, I strongly encourage this. Don't take the next step until you're sure that the step you've just taken is actually working. Baby steps. I'm a huge advocate of taking baby steps in writing code. And it may seem a little slower than you might be used to, but my experience has been if you take baby steps and don't take the next step until you're sure that this one is working, then in the long run, you will get there faster and more reliably. Okay, so we have the parameters working. And the next thing would be the state variables. Now there are two state variables here. Or actually three. So there's the number in the queue, the number of available servers, and the number served. And that's where did that come from? In this case, it came from the table on the second page, table 1, that lists the state variables and parameters. Okay, so so here again for the implement, what I'm doing is we're separating the creation of the event graphs from their implementation. So for the implementation, at least at first, I'm giving you the event graph, say, here's the event graph, now implement that. Ultimately, when you're doing this for real, you don't get any of that. You have to come up with all of these things. But again, and since you're just learning about this, then we're going to take these steps separate, and then eventually they will collide together. Okay, so we want to refactor this, and you want to be a little careful here. Tell you what, I'll show you what happens if we're not completely careful. Well, actually, one thing is if we forget to make this private, then NetBeans changes that. That to me is a bit of a wart on NetBeans. But let's do this. Another thing we can forget when generating these is to not uncheck the setters. So we need to make sure that we uncheck the setters, and this is true for all state variables. Uncheck the setters and make sure the field's visibility is protected. And then for some reason, their default location is kind of up near the top of the code. I prefer it to be the last method. Okay, so and there they are. We have number in queue, number of available servers, etc. Okay, so that's not going to change anything. But so there's no need to run again. I mean, it doesn't hurt, but we haven't done anything that's going to change the way that we run. But now, state variables. First thing to do is implement the run event. The run event is implemented by the reset method, which does the state transition, and the do-run method, which fires the property changes for the initial state values and schedules the initial events. Now, in this component, if you look at the event graph on the second page at the top, figure 1, you see that there is a run event because we have state variables that need to be initialized. So the only task that the run event has is to initialize these state variables. And so the only implementation of the code is to initialize the variables in the reset method and fire the property changes in the do run. So the do run method is not going to schedule anything. So let me just show you what that looks like. Okay, so here's the reset. Oops, not probably, it should be public, sorry. And the first call on that should always be to reset it. Now this is not automatically done for you, but it's something that you should just do as a matter of course. Okay, so now we need to initialize our state variables. And where do we get that? We get that from the event graph. We get that from the run event of the event graph. So the number in queue is initially 0. The number of available servers is the total number of servers. And the number served is 0. Okay. So again, the state transition for the run event, that is to initialize the state variables, is done in the reset method. And why does it do it that way? I'll tell you later. Now, to turn an event into a kind of a working piece of code, we take the event name and we put the word do in front of it. And that's just what it does. I'm not 100% happy with that, but that's what I've been doing for many years with this, and so I'm kind of stuck with it. Okay, so what is the run event in the event graph does not schedule anything, but it fires a property change for everything. So we want to have one for the number in queue. We want one for the number of available servers. And notice that I'm always using the getters in the fire property change. For scalars like this, it actually is not it actually doesn't make that much of a difference, but in other cases, it's actually important to do that. So just as a matter of course, whenever you're firing a property change, the last argument should always be calling the getter. The other thing is that you want to make sure you haven't fat-fingered these names, because as strings, they can really be anything. I have tried to find a way to make that a little more reliable, but without giving up the flexibility, and I haven't found a way. Okay, so we've implemented the run, and the question is, what is, does that actually do anything? Okay, so here's how we can find out. Just as with the arrival process, we can have this simple property dumper. For some reason, okay, well, let's add the import. Okay, now notice I added the constructor has an optional Boolean. We'll see what that does. And now we add that as a property change listener to our SimpleServer. Okay, so this is exactly, this is just for development and debugging purposes. We want to make sure that our state transitions are being properly fired, because if they aren't, then we need to sort of check that. Okay. So okay, so schedule. Okay, so again, just as what we did in the first assignment, for the arrival process, we're going to set verbose to be true. Now, for our final run, we're going to turn that off. But while we're running it, okay, now here's what I'm looking for. What I'm looking for is that the run event is going to be on there. And when it occurs, it's going to fire these 3 property changes. And so I want my simple property dumper to hear that and print that out. So let's see if that is actually what happens. Yeah, I see a bunch of stuff happening. Let's take a look at what it is. So again, we're still passing the right values. That's fine. Okay, so now there's the run event for the SimPleServer. And now the run event occurs, and then notice that we now have three prints, three outputs here for number in queue 2, number of available server, number in queue 0, number of available servers 2, number served 0. Okay, so that is as expected, and kind of the key is this this 2 here, because a variable, an instance variable could be 0 because it hasn't really been initialized. Now, do you notice what that true did? What the true did was it also printed which object was the one firing the property change. See, if I delete that, if I don't do that, then it doesn't tell me which object was doing it. But in this case, since there are at least 2 of them, we can do that. Okay. Okay, so now what I want to do, I'm going to start implementing the arrival event. And what it's going to do is I'm just going to do the state. Well, I'll do the whole thing just because I want to show you at least one. All right, first thing, state transition. Now, for time varying variables, we have this old value, new value thing. And what the convention is to first use the getter for that. Then we directly increment the number in the queue, and then we fire the property change. And so that's and then for these, after the run ones, we have the old and the new. Okay, so let's now how can we test this out? Well, you see, if we just run again, then nothing happens. Okay, why? Oh, for crying out loud! It kicked me out. Does anybody remember what I was doing when I got kicked out?
You only went out for a few seconds, so wherever you stop is good. Okay.
Miracles of modern technology. Okay, so what was that? What I was saying is that, okay, so here I wrote this arrival event, and I want to see whether or not it's going, before I go any further, I want to make sure that that's going to get executed somehow. But see, when I run, nothing all I get is the run event. Okay, why? Because nothing is scheduling this arrival event. How can I get it to get triggered? Well, I need to, now I'm going to define my my arrival process. So and this is the same arrival process that we were using before. That this is basically the one that we did last week. And to make it work, we need another random variate, and we're going to get it now. NetBeans is really being a jerk today. Use that array. Oh, let's say 1.2 just for, okay. And just to be lazy, let's pass that to our inter-arrival time. What? I think did I screw this up? Private, private, private. Screwed that up. Okay, so all right, let's try this again. All right, there we go. All right, let's just make sure everything, oops. All right, so now we got carried away, but at least it was working. So now we need to stop at a certain time. Oh, sorry. Stop at time. Well, when should we stop? Let's the time of 5, just to do that. Okay, so now let's see what we have. Okay, our arrival process. Okay, the value got in. Now notice that we now have 2 run events, one for the Simple and one for the arrival process. Okay, so here's the run event for our Simple. There's the run event for the arrival process. And then here's the arrival, but then we are not seeing this fire property change for the number in queue. But we should. We are not. Why aren't we? Well, because we haven't told it to. So how do we do that? We do it the same way as I did earlier. So the arrival process is the source of the events, and we add a SimEventListener, the SimpleServer. So now the SimpleServer is listening to the arrival process, and now when we run it, let's see what that time was. It was like 2.4. So let's stop it a little earlier. Let's stop it at time 2.5. Okay, so now what I'm expecting to see is I'm expecting to see the number in queue increase by 1 in the arrival. So let's see. Okay, so I'm sorry, number in queue. So okay, here's the run. Okay. First, the run for SimpleServer occurs. It does not schedule anything, but it does initialize our state variables. Then the run for the arrival process is next. So that schedules the first arrival at time 0.24 in this case. Then the arrival event for the arrival process occurs. But then now look at this. The number in the queue is now increased from 0 to 1. And notice it was the SimpleServer. So again, what happened? The arrival event for the arrival process occurred, and it was finished. It dispatched to all of its listeners. It said, hey, here's an arrival event with no arguments. The SimpleServer said, hey, I got one of those. So when it hears the arrival event, it actually executes this method, and we see that it happened right here. Okay, and then, all right, so then here's another one. Another arrival happened, got another increment to the queue. Another arrival, and then another, and should have been 0.25, but okay, that doesn't matter. Okay, so the arrivals are coming, the queue is building up. Again, we've confirmed that this piece is working. Now the final piece is the scheduling. So now at this point, we for any event, we would do all of the state transitions, and then now we want to implement the scheduling edge from arrival to start service, but it has a condition. And what is the condition? If the number of available servers is bigger than 0. That's the condition. So the way to implement the Boolean condition is to wrap your wait delay statement in an if loop, an if block. Now scheduling is done by this unfortunately named wait delay. We give it the, and here's just, you may or may not have noticed, an opportunity for another opportunity for fat fingering is in this wait delay statement. If we fat finger this in any way, including the case, then it won't work the way we think. And then the final piece is because it has a high priority, here's how we do the priority. Priorities are, they're kind of like enums. They're basically public static instance variables. And so by adding this priority high, we implement that little H that's in the circle in the event list. So now, when we run, what we're going to see is, here, let me put that back. So now when we run it, notice that, okay, again, just back to the beginning, just to show to check. We're still getting our parameters okay. We have our 2 run events, and then this, you may notice that the stop event, that is scheduled by schedule, by the event list that says, oh, this is when I want you to stop. So what it does, the way it implements that is it simply schedules this stop event. And what the stop event does under the hood is to just blast away the event list. Okay, so, okay, the run for the server, that's still working. The run for the arrival process, again, if you remember, the arrival process actually fired a property change listener, but we're not listening for that. So we don't hear anything. If you want to make sure that the arrival process is working, then you can add that to the simple property dumper. I'm not doing that here, but that's something you can do just to check. Okay, arrival, number in queue goes from 0 to 1, and it schedules a start service immediately. So now, actually in this case, because start service is happening right away, notice that the event actually kind of occurs, even though there isn't any here. So that's kind of the way, that's kind of by design, because the idea is that when you hear an event, you may or may not even have that event. So on the one hand, it leads to a lot of flexibility. On the other hand, it can sometimes cause some issues where, okay, I see a start service event happening, but where did that come from? Where that came from is the fact that I scheduled this, and as far as the event list is concerned, when it shows up, there very well may be a start service event. Okay, we haven't done anything on that yet. But then the arrivals keep happening, and every time the arrival happens, because S has not been decremented, where is it? Because this hasn't been changed, because that's always bigger than 0, then we keep scheduling the start services. Okay, in the final model, that's not going to be what happens. In the final model, what's going to happen is that if the number of available servers gets decremented, then when an arrival shows up and this